like I have a flu or something. So good morning, Alexander and Aiden. Hey, Isabel, Clay, Damon. Um, let's see, Ella. Good morning, Jacob, Keegan, Natalie. Missed you guys yesterday. Hey, you're Emily and Tony. So missed you guys yesterday. So let's try and do. So I'm going to host this. And I'm going to do Fishing Frenzy for you guys. This is the vocabulary practice. If you could get in there for sure. I'm going to give away a $5 gift card this week sometime for people that are participating this week. So we'll have something by Friday, $5 gift card. So I'm going to host a Fishing Frenzy. These are the 10 words that you need to work on for, I'm going to give you guys 4 minutes. All right. And these are the 10 vocabulary words to look at. We're just learning them. So I really appreciate, hey, Ella, I really appreciate you guys getting in there. Here is the booklet. So again, like I said, there's a gift card coming for this week. It's participation. It's all going to be about the vocabulary, all right? It's all going to be about the vocabulary practice. So there is a link to vocabulary as well as homework assignment. Thanks, Ella. You get in there. Come on, Jacqueline. Let's get in there. I'll give you guys just 2 minutes here to do that. Start up. Stopwatch. Timer. 2 minutes. Get in there. And if you're having trouble, let me know. Let me know. Okay? Public chat. Oops. Work. Look, it does not for me, so I will work. Yeah, you know what you can do, Emily? There is, you look in the assignments for week 7, okay? There is a booklet that you can do by yourself, right? And then you can give your, you can do it there and count the points. If you do the booklet in class, you can take a picture of the screenshot at the end, and then you can post it, okay? I really like you guys to try more than one time so that you get the best score possible, right? So you can do it that way as well. Okay, so where are we? We have 1 minute to go. All right, get into that booklet assignment. Post. Fishing Friendly. Thanks, Ella, Jacob, Todd, Jacqueline, Layla, right? So if you're like Emily and you have trouble with looking at the live version, there is a 10-point bonus, which is homework. Oh, it doesn't? Okay. All right, thanks, Isabel. We have 30 seconds, guys. Get in there. Bryce, come on, guys. Alexander, Silas, Natalie, Damon. Jacob's in there. Yep, Jacob's in there. Jonathan, come on, Jonathan, get in there. Cadence, Keegan, right? Layla's in there. We got Layla. You're gonna have to put your. Are you Layla Brown or Layla C? C or B? We got two Laylas, exact same spelling. Lonnie, get in there. Yep. Okay, time's up. Let's start it. Okay. Fluffordus. Okay, you guys know how to play this. 4 minutes. So tell me who Fluffordus is again. I forgot who that was. Is that? I can write it down in my hours here. This is Tuesday. Oh, thanks, Isabel. Okay, so we've got a participation from Isabel and Alex. Layla, which one are you? Layla B or Layla C? Wait, teacher, I don't know of these questions. Yeah, you just have to keep practicing them, right? Yeah, these are the vocabulary words, so this is just practice, right? Just because you get more than one chance on these, right? Layla B or Layla C? I'm gonna figure that out sometime. Let's see, who else do we have? Ella. Okay. All right, we got Ella down, and I've got Jeremiah. Jeremiah, I haven't gotten back to your question yet because I have to fix it for you. Sorry about that. I was super busy this morning, so I appreciate you if you could give me a little bit more time to answer your question. Here we are, Jeremiah. Thanks for getting in there. And then we got Jacob and Alex. And Alex is it with yeah. Oh, wait, my last page here. And I've got Jacob with B. First page. Jacob, thanks, Jacob. And Clay, thanks, Clay. Thanks for getting in there. Still have trouble. Yeah, I thought it was E. There we go. Clay. Who else do I not have? Todd and Tony. Todd and Tony. Thanks, Todd and Tony. All right, thank you guys for getting in there. 1 minute to go. How you guys doing? Who's in the lead there? Ella's in the lead. Buffiness is in the second. Wow, Ella, you got the vocabulary works down. Okay. So you should get better and better at this as we practice. Okay, so we'll be practicing probably every other day on the vocabulary words. So try to get your. That's okay, Isabel. You're still in that. These are the voting. We're still in that raffle, right? We'll get better. We'll get better. I'll give you guys some Quizlet stuff too. Okay. It's all right. It's all right. Hi, Riley. Hi, Tyler. How are you? Matthew and Lillian. So did we figure out if it was Layla C or Layla B? Can you guys help me out on that, Layla? We have two Laylas here. All right. Excellent. Okay. So today what I'm going to do is I'm going to upload a poll assignment for you. All right, and you can get a link to this. All right, sorry about that. I'm looking at another screen here, so I apologize for not reading right now because it has to upload. I'm door dashing breakfast. Oh, I see. So did we figure out Layla? Was it? Oh, Chambers. Were you playing Layla? Not Layla B? Oh yeah, thanks. That way I can get you down here. There we go. Gotcha. All right, got everybody. Okay, so let's do this. I'm going to turn the screen off here, and it should be loading. Okay, so let me show you what you guys can do. Okay. All right, so here is, we're going to be talking about the Lewis dot symbols, okay? And this is very confusing because most people have not seen this before. All right, so we're getting into deep in the weeds in chemistry. Okay, so what you can do, okay, and I will give you this link here. You can follow along with me in a CAMI assignment and finish these, or you can do this by yourself using the video. So let me give you the link to the modules here, right? So just like the vocabulary words, there's assignments as well as that. So there is, okay, where are we? Week 7. Oh, okay. I don't. Okay, so what I don't have. Okay, I completely forgot to get this. Okay, let me do it right now. Great assignment. So Cami 10-1. So you can write on this. I will go over this with you. I'm not using the Google Slides because it really, oh my gosh, it took forever to load the load everything. Okay, so let me get this for you guys. And again, I apologize for, I was thinking about doing it. All right. All right, this is Tuesday. All right. Lots of bonus assignments today. All right. And this is one of them. So this is 10 points. All right. And it is a bonus assignment, not classwork, bonus. And external tool, up, find. So we're going to use a Cami on this so that, see if this works a little bit better. If you're not used to Cami, I can understand that. It's something we'll practice with. All right, so this is called Cami. And 1, okay. Attach. And I'll give you this link here in a second. Loading up. Okay. And we'll start, it's available today. And it's available till Friday. And then you have it for sure by the end of next week. All right, save and publish. And here is the link for you guys. Oh, okay. So this is the Cami assignment, bonus assignment, right? And here is the link for that. Okay. Sorry it took me so long. So what we're doing today is we're going to be talking about the Lewis dot symbols, okay? And it's just a shortcut way of drawing a picture, right? We do this for help us look at the periodic table. And most people, when they get into chemistry, do the Lewis dot versus the Bohr diagram because it gets to be very, you have to do a lot of drawing. So you can practice here the Plix Lewis dot structure. Hopefully it'll come up on your Cami assignment. If not, I don't know if I put, no, I didn't put it in. Okay, I'll link that to you. Is Deshaun here today? Deshaun, no, Delilah and Dalton, Demarion, but no Deshaun. Okay, his birthday's this week. Happy birthday, Deshaun. Right, so one more thing here. End of the marking period, October 23rd at 11:59. So you must get at least to 60% to pass. All right, so try, and there is a chapter test next week. So if you didn't do chapter 5, test 1, this is chapter 6, 7, and 8. This is chapter 2 test. So going over this week's. So that's another 60 points. So you got to get that done before the end of October. All right. Yeah, and I don't have anything that I can do for you once once we got to the deadline. I can't. If it's like 59%, it's not 60. It's not much. I cannot do anything, right? Unless I can add some bonus if you're doing bonuses. But right, you need to get as good a grade as you can. Try those several times. Take your time looking at your notes and so forth. But the deadline is coming in 3 weeks. All right. Okay, so let me ask you this question. So which of these is a Bohr atom model? So if you looked at the video yesterday, you should have seen the Bohr atom model. One of these is the older model. The older model, it's called the planetary model. Is it A or B? All right. Thanks for getting in there. I'll give you guys 30 seconds. Let me get the timer going here. Timer. Let's do timer stopwatch. Start. Okay, there we go. Timer, 30 seconds. Okay, so I do not know. You basically pick one or the other, Bryce or Isabel. Just pick one or the other, right? A or B, right? Okay. Just want to know what you know. You can guess A or B. 30 seconds, 6 more seconds. I've got 16, 17, 18, 19. Okay, publish the poll. All right, it is B. So in the Bohr model, right, they have, this is the planet. There is a specific arrangement of the electrons, okay? So it looks the same except for they have rings or circles, and the first circle or shell can only have 2 electrons. The second shell can have up to 8, and then if it gets over 8, then they add a third shell. So it has distinct energy levels. The energy of the electrons closest to the nucleus they're the strongest electrons. They're being pulled into the nucleus because of the positive charge, and those are the ones that they have the highest energies. All right, so what's the main feature of the Bohr atomic model? Right, you have protons move freely around the nucleus. Energy is absorbed by the atom. Neutrons are found outside the nucleus, or electrons orbit the nucleus in fixed energy levels. Okay, so protons don't move, right? So for those people that are putting protons move, right? They don't move. They stay in the nucleus. Only thing that flies around are electrons. So the only electron answer is letter D. Electrons orbit in fixed energy levels, so that's why we have this. We have these rings, and then we have the configuration, 2 electrons in the first shell, and up to 8 in the second, and up to 8 in the third, or 18. All right, so I'll give you guys about 10 more seconds at 2:30. All right, so I could use 4 more people putting letter D, right? Letter D. Letter D, if you can get letter D. All right, we are done here. Okay, so it gets pretty confusing. So this is a good time to make sure you're writing notes down, making sure that you know what these answers are. Okay, this is one of the answers to the vocabulary that we'll have a post test on. So you need to know that electrons are the things that orbit, and they're in fixed places. Shell 2 and shell shell 1 and shell 2. So they have places they go. Protons do not move. Energy is absorbed by the atom. Well, it can be, but we're not talking about the main feature of the Bohr. Neutrons are found outside the nucleus. No, they never are found outside the nucleus. They're always inside. So protons and neutrons stay where they are. All right, so this is a review from yesterday's assignment. So if we have time, I'll go over yesterday's assignment for these assignments here. Atoms are made up of protons, neutrons, and electrons. The type of element is determined by the number of protons. So anything with 6 protons is a carbon, right? The type of element, neutrons, if we add more neutrons to the element, so basically neutral atoms, we still can have carbon, but we can have it way more, okay? It has it. So if we had an extra neutron in here, it'd be like 13 total. So isotopes come in every, just about every element. Some of them are radioactive. Some of them, they just happen. That's why there's an average there. But most of these, because if we round this up to 12, of them are carbon 12. All right. Protons and neutrons together make up the mass. That's why this is 6 and 6. So most of the mass of carbon is 6 protons, 6 neutrons. And the element's average atomic mass is at 0.011, means that there's carbon 13 and carbon 14. And sometimes you guys have heard about carbon 14. All right. Electrons are negatively charged particles in the atom, which is opposite to the proton's charge. They are tiny. The electrons are tiny, do not affect the mass of the atom. because it takes like 2,000 of them in order to make a neutron or an electron, right? So we're going to be talking about neutral atoms today. So that means that we have the same number of protons as electrons, same number of electrons as protons, okay? The same number of protons and electrons. And remember that protons is called the atomic number. And if you look at aluminum, the atomic number for aluminum is 13. That means it has 13 protons, right? Atoms that have more protons can be positively charged. More protons and electrons positively charged are called cations. And how I remember this is they're positive. The cat is a positive. Think about the paws a cat has, right? So here is kitty cat with whiskers, all right? And we think of that as positive. And that means the only thing that you can change on an element is the amount of electrons. You can take them away or you can add them. It does not change the element. You cannot take away a proton. It's a totally different element. And then more electrons than that. So I think about anion and I think about peels, okay? And it's pretty negative. I don't want to eat an onion, anion. It's negative. So that means there are more negatives. Here there are less negatives than protons. Okay, so those are your vocabulary. We'll be talking about those more next week. All right, so here's where we're going to do the Lewis dot. Follow along with me. Okay, so what we have to do is find out what the valence electrons are. All right, so a valence electron is an electron on the outermost shell. All right, so valence is the outermost shell. And notice that this one and this one are the outermost shell. So this is a Bohr atom. Bohr atom shows 2 electrons here, and then this has 2 electrons on this shell too. So, so the protons and neutrons here. So we would have, I don't know why they drew this right like that. Should have an extra proton. So this one should have protons, right? And 4 electrons. But we put 2 because Bohr atoms say can only get 2 in the first shell and then up to 8 in the second shell. All right, so let's take a look at this here. All right, so let's see what we remember here. What are valence electrons? Are they electrons in the outermost shell? Are they electrons in the nucleus? Because electrons are never in the nucleus. Are they electrons in the innermost shell? So these are the innermost shell. Are they electrons with negative charge? They always have negative charge, but that doesn't mean they're, so it's either innermost or outer. Okay, not in the nucleus. All right, not in the nucleus. All right, so, okay. So I'll give you guys 10 more seconds. Let's make it 8:40. 10 more seconds. So it says right there, outermost shell, right? Outermost shell. So that's one of those things where you have to draw a picture of and describe it. It's a lot of information this week, So we'll be having lots of help sessions. And we're doing that, the targeted sessions. We're all talking about valence electrons, okay? All right. So most of you guys got it. That's outermost shell. And you can see outside, it's furthest away from the nucleus. Okay. All right. So there are 2 types of atom models. The Bohr model shows all the electrons. So see here, the Bohr magnesium has 2, 8, 10, 12 electrons, 2 in the first shell, 8 in the second shell, and then 2 in the third shell. And we draw just those 2 valence. That's the ones that do the bonding. Those are the ones that do the bonding, and those are the ones we're concerned about. We don't need to know how many. We just need to know the valence electrons, because the outermost shell does the chemical bonding. And when the magnesium connects with chlorine, right? It connects with it in a particular way, and we'll be talking about that. All right. Okay. So here is the way you do this. Write the symbol of the element. So we don't have an X, we have an XE. So then we determine the number of valence electrons, and we can do that by looking at the periodic table. Add the appropriate dots in order, so you can start at the top. I usually start at the top. I go 1, and then I go to the right 2, the bottom 3, then 4. Then if there's more than 4, then I go 5, which is next to the 1, 6, 7, and 8. Okay, so that's what happened with argon. Okay, so that is how we do that. So let's practice that, okay? All right. Okay, so let's take a look at the periodic table. All right, and I'll give you guys this link here real quick. All right, I'm going to clear the chat. I'm going to ask for some participation on this. So if you are getting it, I would appreciate you giving me some participation here. Okay, so let me draw the neon for you, right? If I look at the neon, all right, and this is the P table is the best one to look at, okay? So if you look at this, I'm going to go over to neon, and if you'll notice, it has 10 protons. And then over here, it tells you in the first shell, there are 2. In the second shell, there are 8. Okay, so we're only worried about the 8. That's all we're worried about. So when we look at the P table, so hydrogen has only 1 electron in the outer shell. Lithium has 2 and 1. All right, so let me ask this question for you guys. All right, so I'm going to give you an element. Let me give you a poll question. Start a poll. How many valence electrons? Okay, valence. You put the number in. So if you guys are getting these answers wrong, then please get some help from me or the targeted learning session. Okay, so typed answer, start a poll. Beryllium. Let's do sodium. Okay, how many valence electrons in this particular one? It says 2, 8, 1. You have a choice of 2, 8, or 1. What do you think? How many valence electrons in the sodium element? Nope, not 2, not 8. The outermost shell is always the bottom one. The outermost shell is always the bottom one. Okay, it's always 1. There are 3 shells, 2 in the first, 8 in the second, and 1. All we're going to worry about is how many in the outermost shell. This is the outermost shell, the one in the bottom. All right, let me try another one. Thanks, Bryce. Okay, let's try again. Publish the poll. Start the poll. Okay, so let's type this one. Okay, so I'm going to give you aluminum. How many electrons? Look at the number at the bottom. The last one is the number of valence electrons in this aluminum. So it's not 2, it's not 8, it's what? What is it, Bryce? Okay, Bryce, I just showed you. I said it's the last number. Can you see this thing here? Put it in the chat for me. Right? All right, so it's 3. And again, there's no 1 in there. Okay, we're looking at the 2 in the first shell, 8 in the second shell. The outermost shell is 3. Publish a poll. Let's try another one. Start a poll. All right, let's try calcium. Okay, there are 4 numbers here. Look at the bottom number. Type the response. What is it? What is it? This number right here. Thanks, Lonnie. Thanks, Todd. Thanks, Jacob, Isabel, Dalton. How about you, Bryce? What number are we looking at? What number are we looking at? Thanks, Jonathan. Not 8. It's the last number. It's the last number. It is number 2. That's how many electrons in the outermost shell. Not 20. We don't add them up. Guys, make sure your microphone's on. It's 2. Make sure your microphone's on. We don't add them all up. We look at the last number in this list, right? So 2 second shell. I'm sorry, 2 in the first shell, 8 in the second, 8 in the third, and 2 in the outermost. 2. Okay. And if you're having trouble with that, we can work on that some more. All right, so let me stop sharing here. Okay. Okay, so boron, here is the atom of boron, has 2 electrons in the first shell, 3 electrons in the second shell, and all we do is put 3 dots. First, second, and third. Okay. Silicon, right? Has 2 in the first, 8 in the second, and 4 in the third. So you can see why we're using the Lewis dot, because we don't want to have to draw 4 circles and then put all the electrons in there, right? So we just look at the 4 dots here, right? And here is antimony. It has 1, 2, 3, 4, 5 shells, and it has 5. And it doesn't mean that because it has 5 shells that there are 5 electrons there. It could be more than that. So we just draw those out. Okay. Let's try some. All right. So if you've got that link, anybody still need the link for the assignment? I'll give it to you again. Cami, here is the link to Cami. This is your assignment today. All right, and we're running out of time here. So this is the Cami link. All right, maybe put this on the top here. Right? Okay, let me get that out of there. X, V. There we go. So if we look at hydrogen, notice the picture here. If I look at the P table for hydrogen, and I'll show it to you real quick, right? And if you need to look at it yourself, here is, and it's one of those things where, yeah, that happens, Alexander. Thanks for letting me know. Here is the P table. Share. All right, so if we look at hydrogen, it says 1 electron. Okay, so let's draw the hydrogen the way we do this. Okay, so what we have to do in this particular case is we draw the number of protons in the middle. So I'm going to use my drawing here, right? So I'm going to draw, if I can use, all right, here we go. So we're going to put 1 proton here in the nucleus, and then 1 ring around, and 1 dot. That's all hydrogen is 1 proton, 1 electron. Sometimes they have more electrons or less electrons and then become an ion, but we're looking at neutral atoms because the positives and the negatives balance out. So when we draw the element, we draw the hydrogen. Okay, and from the notes it says you can either start at the top or the side. So let's start at the side. On the right-hand side, I'm going to put 1 dot. Okay, tell me if you're done with that, okay? How do you know that electrons, not the protons or something? Okay, so the number one here is the proton, right? And then we're going to say that there is one electron to make it balanced out. So one electron and one proton gives you, so if you have this information and you don't have your p table, right? The p table tells you exactly how many in the outermost electrons. All right, so that's how you work that. Okay. How many need more time on that? Anybody else need more time on that? Okay. Anybody need more time? Picasso, yeah, it does look like a Picasso. My face sometimes looks like a Picasso. All right. Okay, looks like everybody's done with that. Okay, so phosphorus, let's go over to the P table, all right, and I'll put this information down for you. Okay. So phosphorus, it's right here. Okay, there it is. And it says 285. Okay, 285. Let's put that down. Stop sharing. Okay, let's do this. 285. All right, so I'm going to write on this. So the nice thing about this, when you write down on here, I always do this, 285. That means, okay, there are 15, and I'm just going to put 15 pluses, okay, plus 15 for my protons, okay? And I've got to have 3 circles. 1, 2, I'm going to put a smaller circle in there. 3. Okay. So it says 2 in the first shell, closest to those 15 protons. And we're going to add, so 2 plus 8 plus 5 is 15. So now we're going to do 8 right here. 1, 2, 3. Now the reason I draw them further away from each other because they are repelling each other. 1, 2, 3, 4, 5, 6, 7, 8. And then there's 5. And let me use a different color maybe to make it more noticeable. Let's do blue maybe. Okay, so 1, 2, 3, 4, 5. Okay, so what I'm going to do for my phosphorus, I'm going to write the letter phosphorus, the capital P. Don't write a small p because they come in 2 letters. The first one's always capitalized. If they come in 1 letter, just capitalize. How many dots am I going to put in? How many dots am I going to put in? Anybody know? What's the outermost electron shell? How many in the outermost electron shell? 2, 8, or 5? 2, 8, or 5? Thanks, Todd. You're right. So we start here. Let's start at the right-hand side. Go like this. 1, 2, 3, 4. And then what we do is we double up. 5. So start at the right. You could start at the top if you want to. It still works, but there's a one doubled up. So you can see how the Lewis dot is so much easier to see than it is on that particular one. Okay. Yeah, probably because you have so many things open. All right. Okay. So we have 5 minutes left in class. Let me stop here. Did Deshaun make it? Let's see, Deshaun, nope, his birthday's, well, let's see if we can make it come for, and thank you guys for getting in the assignment this morning, the booklet. I got about 7 of you. Appreciate you guys. I know it's hard coming back on a Tuesday when you were sleeping in. How many people slept in yesterday? Anybody sleep in yesterday? All right, Isabel. Yep, I would too. They made me come to class at 8. Yep, almost did. All right. All right. All right, sleeping in. Yeah, you're right. You're right. Well, hopefully everybody got their 5 hours in. That was the quick nap. All right. I did. My alarm went wrong. Okay. Yeah. Hopefully you guys get your 5 hours in. Now, if you didn't get your 5 hours in yesterday, let's say you got 3, put in 2 extra hours today. So go with 7, right? Right. Thanks, Francesca. Thanks for being honest. Oh, all right. You got told. Okay. All right, guys. Love you all. I will see you this afternoon. No, tomorrow. See you tomorrow. Wednesday. Oh my gosh, hump day already. All right. Bye, Todd.